Hello everyone, Moritz here again. And today we're going to look into GIS integration of how to convert continuous climate data into categorical classes, which then can be used for species distribution models and similar applications. To start off with, I will talk about the concept of what is continuous climate data. And then we're going to talk how can this be classified into classes and how that's important for species distribution models and how this can be done. To start off with, I will start with a very blank QGIS file where we're going to import a continuous climate data, and I'm going to explain why continuous climate data is important for species distribution models. And I will also give an example of why it can be important also to classify that continuous data into a lot fewer categorical classes. So we're going to import a raster of continuous climate data. Navigate to where I have stored these. Here you can see I will load a bioclimatic raster which illustrates climate data of the whole world. And here you can see that the data ranges from minus almost 55 degrees Celsius all the way to plus 31 degrees Celsius. And these rasters are often used for species distribution models because they identify very similar climates for the species that are to be modeled. And this is commonly used. However, it can also be classified into, let's say, 3 different classes, which can then be used for the species distribution models when the study which the species distribution models are going to be used for is looking at a certain limits, certain temperature limits. So, for instance, if I were to look at the survival of a certain species, I know that the thermal limits are between plus 15 degrees Celsius and plus 25 degrees Celsius. Then what I would do in this case, if I look at the whole range of this raster, I would cut off the negative parts, everything under 15 degrees Celsius and everything above 25 degrees Celsius. And then I have 3 classes. I have the lethal limit or lethal range in negative part and lethal range in the positive part. And then I have a minimum, an optimum, and a maximum, basically. And this can be very, very useful in studies which look at the thermal limits of species and how these, and whether this distribution of those species is based on climate and the thermal limitations. And now I will go with you through the whole process of how to import these climate data, how to divide it into the certain classes, and how that can then further on be used for the species distribution models. So the very first step is to import the climate data. Here, what I just imported was just an example. Now, to import the ones that we actually need, I'm going to import different ones. And I will be back when I have to import it. Here, I have my data depository where I have all the data stored which I need for this certain study. And I have done all this process already for all the months except for December. And I'm going to run you through the whole process for December only. So the file for December, I'm going to open this. I'm going to delete the other one because it might be not useful anymore. And we're going now to, in our study, the one I'm currently working on, has the thermal limits of plus 15 and plus 35. Because this range, this only ranges until plus 33, it is not necessary to make 3 classes, but 2 classes are enough. So in this case, we are still going to create 3 classes, even though it's not necessary, but just for demonstration purposes, I will still create 3 classes. What you have to do now when you want to classify these rasters is you first have to split them. So you have to right-click, export, save as. Right now we're always talking about TIFF files, TIFF rasters. Now we're going to export this raster again into a clipped version. So we're going to select the directory where we want to save this file, and we're going to save it in this directory. I'm going to call it December lower limits, because we're starting with the lower, then we do optimum, then we do higher. Lower limit, and we're going to save it. I'm going to scroll down. You also have to check that the extent is the one you also need for your species distribution models, as well as the resolution. Afterwards, we scroll down, and for no data values, we check the box, and we select the no data values. So since we're here looking at the lower range, we say for no data values, everything which is above plus 15 degrees, because our lower thermal limit is plus 15 degrees. And now we're going to select all the data which is above 15 degrees. So here we start with plus 15, and it goes all the way up till plus 33 in our range, just to be sure we can make this very high, plus 45. And then this takes a few seconds. And then we repeat this for all the three classes we want to have. So I just did it right now for the lower part. As you can see, this file now only shows the data from the very lowest what we have until 15 degrees Celsius. The next step is to define the optimum range, which is from plus 15 to plus 35. So I'm going to repeat this step. I'm going to select this. We're going to select December. I'm going to call it optimum. And again, we scroll down, and here we select for no data. In this case, we have to select optimum range. So we have to put as no data values everything which is not the optimum range. So we do minus 55 degrees until plus 15 degrees. And also from plus 35 degrees until plus 55 degrees. So it takes all the values which are not in the optimum range as no data values. And here it is very important that the lower number is always on the left side, otherwise it won't work. We say again, okay for this. And afterwards, we're going to repeat the same for the upper boundary, which is not necessary for this study again, but we'll still do it. As you can see here, this would be the optimal range for this very species. In this case, you would do again, export, save as, and here you do it again. December up, upper boundary. Save this. We say no data from minus 55 degrees until plus 35 degrees. So we take away everything under 35. We say okay. And since there's no data above 35 degrees, we should not have anything that come out of here. And that's what you can see here. So this was redundant basically, but for purposes here, I did it anyways. The next step is to vectorize these sub-ranges. So as you can see here right now, these are all rasters, which are important. We also have to rasterize afterwards again. But right now, the next step is to vectorize these. I'm going to do this only for these two because the third one is not necessary. There's nothing to be vectorized. This can be done again in GIS. We select one of the two. Let's start with the lower one. We go to raster, conversions, and then polygonize. This transforms a raster to vectors, which is what we want. Click this, it is already selected. Here the name of the field is already there, which is great. And we won't have to select the directory where we want to save this file. I'm going to do this again in the same directory because this is where we want to save them. Call again December low, because this is a shape file. We want we're going to click run, and this might take a while again, but once it's done, I'm going to be back. I'm back, and as you can see in the background, it has created these polygons. So we went from raster into polygons. Now we're going to repeat the same for all the other classes. In case you have more than 2 classes, you have to repeat for all the classes you have. We're going to use it only for these 2, and we're going to just repeat it for the second one. Here it is not necessary to again go through the whole directory. You can just change here as indicated by me here. It's sufficient for the right directory. You run this again. This might again take a couple of minutes, but it should be relatively fast. And once this is done, I'm going to be back. I'm going to speed this up. Okay, I'm back again. And as you can see in the background, all the rasters have been transformed into polygons. And what we have to do now is we have to unify all this continuous data into one individual climate number, basically. And this can be done by dissolving all polygon classes into one class. And this again can be done in QGIS. And this might take a bit of time, especially on a global scale, but I'm going to run you through this anyways, and I'll speed it up afterwards. So to do this, we have to deselect all the ones that we're not currently using. And with the mouse, you have to click on the one that you're interested in the left layer panel. This is very important, otherwise it won't work. And then select on the top, select features, and then you draw a rectangle around all the whole layer. Then it is selecting all the polygons within that layer. Once they're selected, we have to go to Vector. We're going to select Geoprocessing Tools and then Dissolve. As the first thing here, we have to select Selected Features Only, and we're going to define a directory where we want the saved file to be stored. I'm going to do this again in the same directory. I will call this December Optimal Dissolved. Okay, and run. And this again, as discussed before, might take quite some time, even up to half an hour or more, depending on the scale and the amount of numbers in the continuous data range. And I'll be back once everything is completed. All right, welcome back. As you can see here, this just got done. And as you can see in the background, this was the previous file with all the different polygons. And these have all been dissolved to be one polygon, as you can see here, with one value each. They all have the same value now. The value itself does not really matter, because in species distribution models, it's not necessarily the value itself what counts, but the proximity of the individual occurrences to others that matters. So it's rather the proximity to others than the value itself. And to conclude this step in QGIS, we have to repeat this also for all other classes. So I'm going to repeat this for the other class I'm using here. And here again, I have to be, for instance, now I don't have the mouse selecting the one that I'm actually interested in. And as you can see here, it won't work. So I cannot select the layer. So I have to click on this one, the one I'm interested in, and I can select the entire layer. And as all of this is selected now, we're going again to Vector, Geoprocessing Tools, Dissolve, Selected Features Only, and then we're going to save it where we want to have it saved, and then we have to wait again. And run this. And I will be back again once this is completed. Welcome back. As you can see in the background, the polygons have been dissolved, and now we have basically these two dissolved layers. And they're complementary, of course, so they together form one layer. And now the next step is to rasterize them again, and then merge them. And the best way, like this rasterization can also be done in QGIS, as you can do here, raster conversion, and then rasterize, so vector to raster. However, in my experience, this is a little bit difficult with settings. So when you're working on a global scale, there are certain settings which are different for each layer for some reason. And therefore, I would suggest to do this in ArcGIS. So I prepared here a empty map of ArcGIS, and I will walk you through this process in ArcGIS. And the first thing is we have to add the data. So we have to select it from my directory where I have saved it. As you can see here, I just select these and import them into ArcGIS. Once they're imported, we're going to rasterize them. So we're going to analysis. We're going to unselect these baselines, these base maps. And I'm going to analysis, tools, and over here we're going to look for feature to raster. Feature to raster. I'm going to select the import feature. In this case, it's this one. Then we're going to select, what's very important is to define the output cell size, which is the same one as the one that you're going to use for the species distribution models. And I'm going to copy this one from my climate raster in GIS. I'm going to properties, then information, and here I'm going to copy this pixel size. And this is determining the cell size of these rasters afterwards. And then we're going to also select the output raster. So we're going to select the directory where it's going to be saved in. And because this is again a raster, it will not override the existing shapefile. And then we also have to go to the environments, and we're going to select the output coordinate system we want to use. In this case, I'm using the WGS 1984, and there this is not needed, and the extent is it's a very common one. I'm going to select it from one of my other layers, as you can see here, with other rasters, including the species distribution models. And you can either import the file into ArcGIS and then select it from there, or directly import it here. And once this is all selected correctly, we're going to check this, and we're going to run this. This is now rasterizing the dissolved polygons. This was now pretty fast. We're going to repeat this for all our categories. Then I'm going to run the second one. And once these dissolved categories are rasterized, as you can see here, I'm going to unselect this so you can see them. They're rasters now. If you zoom in, you can see the different pixels. We're going to import this rasterized category in QGIS again, where we're going to continue with this process. Because the next step is to merge these two. So we are going to import them. This is again a raster now, so we can import them as rasters. As you can see here, you can select them wherever you save them. I save them here. going to import that. And then ideally, they should look the exact same way as in ArcGIS. However, there are sometimes issues with that, and it can be solved, of course. Whereas, for instance, for this one, it worked perfectly. Whereas for the other one, there's some kind of issues you can see here. A possibility is to look into the properties and the symbology and change that into this setting and see if there is a possible coloration mismatch, which in this case is not the case. Otherwise, there would be two layers. It would be like black and white, but there was just one. So what we have to do now in this case is that we're going to export these TIFF files. We're going to transform them into ASC files. And the ASC files can then be viewed as a text file. And in text file, we have to adjust the no data value for these two files. So I'm going to raster, conversion, translate. I'm going to export these as ASC files. I'm going to convert, save file, and you have to select a directory for this. I'm going to use this directory here and call it and we're going to transform this. This has to be done for all the ones of all the classes that together form one whole raster. We repeat this for our second one. And as the next step is we're going to this directory where we save these. Once it is fully downloaded. And then we're going to look for the ASC files. As you can see here, they're on the top here. And there's a very useful app for this. It's called EM Editor, which can open big text files. As you can see here, no data value is 1, and there's many ones, which indicates that 1 is likely in the no data value and everything is correct. We're going to look into the second one. We'll repeat the same process, and as you can see here, the no data value is indicated as -128. However, all the values that can be seen here are +128. So we're going to adjust this. We're going to remove this minus. We have to save this file again. And then this can be closed and imported again into GIS. These ASC files are basically rasters and can be imported just like as rasters in QGIS. I'm going to update this, and you can see them here. Open them, and it technically should work now, and you should be able to see the differences. And as you can see here, we can perfectly see the whole globe in comparison to before. And now we have to again transform these ASC files into TIFF files so they can be used and they can be merged and then used for species distribution models. So I'm going to export them as a TIFF file indicated above. We have to select December solved. And then you have it's very important to also check the extent here. Again, as you can see here, there's a small mistake here. We can adjust this by selecting the correct one. This afterwards helps us to avoid mistakes. We do this again for both our classes, or all the classes we have. Correct this, and then we select the directory we want to save this in. This is number 2. Repeat it. And then once they're both, again, translated into TIFF files, they can be merged. The merging process, we're going to execute that again in QGIS. And as you can see here, they perfectly form the globe or study area, which before was unfortunate. You can see here not the case. For the merging process now, we're going to use these 2 files. We're going to rasters and then to merge. We're going to select our rasters that we want to merge. We want to merge this one and this one. And here for input pixel value as treated as no data, commonly it is suggested to put 0 here, which we'll also do. And then we're going to scroll down. We have to select a directory where we want to have this file saved. Here I have to select TIFF files again, and I want to say December merged. Save this, and we have to run this. If everything has worked correctly, and all the no data values have been assigned properly, this should be no problem. And there should be now technically 3 different classes. There should be one assigned to no data value, so in this case, all the ocean. And then one value should be one of our rasters. Now here we can check this. In the properties, we're going to select paletted. We're going to classify this. And in this case, unfortunately, there was some kind of mistake, and there are only 2. So we're going to check which ones have been gone wrong. And there are 2 options. Either this merged one can now again be merged with the previous one. So for instance, with this one, and then it is possible that the error can be avoided, or all the no data values have been repeated. In this case, we're going to try to merge these 2. As in, with experience, it most of the time works and is pretty straightforward and useful. So we're going to merge these 2 again. Going to select rasters, merge. Going to select the low one and December merged. Okay. Here we can say the no data value should be 8. This should be 2. And this is some kind of exercise now where you have to play around a little bit to figure out which option works best for your predictors, because there's many things involved, many no data values involved, and it is kind of a game to figure out which one works best for you. In this case, it worked well. As you can see in the background, our new raster has been produced. If we now change the colors so it can be seen better, you can see that there are 3 different colors. One is for the ocean, one is for the lower limit, and one is for the optimum. And now this exact raster can be used in species distribution models. Now, these are TIFF files. for species distribution models, especially the ones performed in Maxent, have to be transformed into ASC files. So I'm going to transform this now into ASC file. I'm going to shortly check if all the details are correct. So the extent is correct. Also the width and the height are correct. And the pixel size is also correct. So this is great. So we're going to transform this into ASC file. So we're going to raster, conversion, translate. Going to select directory, one I have to save this in here. And we call this here we have to select ASC again, and here I'm just going to use this and save it. This has to be transformed, and then these ASC files can be used as species distribution models. I created a whole video about species distribution models and how these can be performed. So I'm not going to repeat it here. I would refer you to check out that video, and I will likely include a short I will likely include now a short section where I actually do run this in Maxent. However, I will not narrate it. It will just be a very quick introduction, very quick overview in how that can be performed. As you can see here, the species distribution model is running. Thank you very much for watching this video. I hope you enjoyed it, and please let me know in the comments or via email in the description if there are any further questions, or you're also very free to contact me via ResearchGate. Thank you very much and have a good day. Bye-bye.